Now, what are the challenges in the design and application of machine learning? First, data comes in all shapes and sizes. What does it mean? Real-world data sets can be messy, incomplete, and in a variety of formats. You might just have a simple numeric data, but sometimes you're combining several different data types. For example, sensor signals, text, audio, streaming images, and so on. Second, pre-processing your data might require specialized knowledge and tools. For example, to select features to train an object detection algorithm requires specialized knowledge of image processing. Different types of data require different approaches to pre-processing. Third, and finally, it takes time to find the best model to fit the data. Choosing the right model is a balancing act. As we mentioned earlier, it is a trial and error process. A flexible model tends to overfit data by modeling minor variations that could be noise. On the other hand, simple models may assume too much. There are always trade-offs between model speed, accuracy, and complexity. So please be mindful that there is a trade-off between how fast your model will be built and predict, and at the same time being accurate. So which of the two should we consider? Again, we'll go back to the situations of our application. Which of these two is your priority? Are we after how accurate the model can predict, or are we after the speed of or how fast the algorithm will be able to predict, especially in real-time applications? Now, we try to identify the questions to consider before we start building our machine learning models. Every machine learning workflow begins with the following three questions. First, what kind of data are you working with? Make sure to analyze first what is the available data set. Is it a historical data set? Is it from a database repository? Is it a sensor data set or an image data set? Will it involve categorical classification or numerical classification? And so on. Second, what insights do you want to get from it? Like what labels or what predictions you want to get out of this huge amount of data. And finally, how and where will those insights be applied? Will it be applied for home automation, for healthcare monitoring, for robotics, or self-driving cars? Now, choose supervised learning if you need to train a model to make a prediction. For example, the future value of a continuous variable such as temperature or a stock price or a classification. For example, identify makes of cars from webcam video footages. On the other hand, choose unsupervised learning if you need to explore your data and want to train a model to find a good internal representation, such as splitting data up into clusters.